So we're still talking about evaluating limits, right? We did that. You guys did that on Thursday and Friday. You did it with a graph, right? They gave you a graph, they gave you a picture, and you evaluate it. We're going to do the same thing. We're going to do the exact same thing, except we're going to use the other two methods. Okay? So we did the one I highlighted in green. We did that last week. Okay? So when we had a graph, let's see. Let me pull up what we did last week. Right? When we had a graph, we were able to find the limits using the left and right. We did that, right? That's what we did. Today, they're not going to give us pictures. They're not going to give us graphs. They are going to give us equations or tables. So using a table. The thing about a table is they rarely use it. They rarely ask us to use it. So, which is nice. But I want to show you how to use a table. The one they most likely going to do is number 3. Number 3 is analytically, algebraically, right? Using algebra, the way you're most familiar with and the most common method. So number 2 will take us not very long because it's not a very long method. Number 3 is the one we'll be spending most of our time with because there's different examples I want to give you. Okay? So the one that's rarely used, the table. How do we use a table? So example number 1. So it says use your calculator to generate. I already did this on the calculator. So I made the table. So how did I make the table? Well, I plugged in each of those numbers. 1.5, 1.75, 1.9. I plugged them into the formula here, or to the f of x. Okay, and that's how I got the numbers, right? So first of all, the equation f of x is x squared minus 4 divided by x minus 2. But it says x cannot be 2. That's what that little exclusion means, that little part right there. Under no circumstances can you use 2, or will 2 work? Why won't 2 work? First question is, why is 2 excluded?
Because if you were to plug in 2, it would be 0 on top of 0, and you can't divide nothing by nothing.
So yeah, it would be a fraction with 0 on top of 0, right? One of those is okay. One of those zeros is okay. One of them is not okay. Which 0 would be okay? Is it okay if I have a 0 on top or a 0 on bottom? On top, right? So let's say I have 0 over 12. That's okay. That just means there's 12 slices of pizza. I don't get any. That's possible, right? I could have none, right? But you can't have it the other way. I can't have 12 over 0. Because think about that. That means you get 12 slices of pizza. How many pizzas are there?
0.
How do I get 12 slices of something that don't exist? It doesn't work, right? It doesn't work. So that's why 0 on the bottom doesn't work. It's not a number, right? If I put it this way, if I put it 0 over 12, there's 12 slices. I get 0. That could happen, right? But I can't have it the other way. There can't be no slices and I get 12. That doesn't work. So when 0 is on the bottom, we say it's undefined. So why is 2 included in the function? Because x equals 2 is excluded from the function because we can't have 0 on the bottom. 0 on top, totally okay. 0 on bottom, we can't have. Did I not give you this paper? There you go. Huh? Yeah, 0 on top, okay. 0 on bottom, can't have. That's why we say x equals 2 is excluded from the function. Anything else will work. Okay, so how did I get the table? I plugged in all of these values. I plugged in all of these guys here. I used my calculator early, and I plugged them into here. So 1.5 squared minus 4 over 1.5 minus 2 is 3.5, and so on and so forth. Okay, so now the question they might ask you is the limit as x approaches 2 for f of x. Right? This kind of looks like what we saw last week, right? Except we were looking at a graph and not a table. So can you tell where x is going before 2 and after 2? So before 2, it's 3.5, or sorry, not x, f of x, right? Y. Y is 3.5, 3.75, 3.9, 3.99, 3.999. Where is that side going to? 4. It's getting closer and closer to 4. Okay. How about the other side? 4.5, 4.25, 4.1, 4.01, 4.001. Where is this side going? It's also going to 4, right? It's getting closer to 4. So both sides appear to be approaching what number? 4. So we say the limit is 4. Okay, the limit is 4. That's how you read a table. Anytime they give you a table, they'll fill it out for you. It's pretty simple as long as you know what to look for, right? As long as you know what to look for. So x approaches 2 from the left, x approaches 2 from the right. So this would be x approaches 2 from the left. So we would say that's negative. And x approaches 2 from the right, we would say that's positive. The positive side, the negative side and the positive side. For there to be a limit, they both have to approach the same number. In this case, they do. They approach 4. Now, is it ever going to get to 4? No. Because when I plug 2 in, it gives me 0 over 0, right? So we'll never get to 4. So what's the answer? What is f of 2? Oops, not f of x, f of 2. What is f of 2? Doesn't exist, yeah. Undefined, no solution, any of those. But the limit is 4. That's how they're different. Okay? That's how to do a table. So now, let's do the method that we're going to use most often. Algebraically, analytically, whatever you want to do. Okay. So they've given us a graph last week. They've given us a table just right now. The third way is give you an equation. Actually give you an equation. So this is my hit list of things to do. Which one works? Whichever one works. Which one do I use? Sorry, which one do I use? Whichever one works. So if you're doing analytically, if you're doing algebraically, the first thing is plug it in. If you get an answer, 1 second. The easiest way is to plug it in. Plug in a number. If you get an answer, move on. If you don't get an answer, you have some methods. Factor. Factor means, let me see, how can I describe it? You've done factoring before. You've done it in Math 2 and Math 3. It's like, if it's, I'll show you an example because I don't want to confuse you anymore with factoring. Common denominator, if you need to add two fractions together or subtract two fractions, common denominator, multiply by the conjugate. A conjugate I'll show you an example of, or others. Okay? So if direct substitution yields a fraction with 0 in the denominator and something is in the numerator, then it doesn't exist. So if we were to plug in an answer, plug in a limit, and we get something over 0, then that's when the limit doesn't exist. Okay, that's what we're going to do. A bunch of different examples I want to show you on how to do these. Okay, so when limits do not exist, well, f of x approaches a different number from the right than it does from the left, right? To be a limit, you have to approach the same number. If it doesn't approach the same number, the limit doesn't exist, right? That's pretty much what that says. That's pretty much what this is. Okay. Okay. The next page. The next page is kind of a reference sheet. The top is a reference sheet on how I do limits. Okay. I put it there just as a reference sheet. Okay. It's a flow chart. If it helps, great. If it doesn't, I just put it there. Okay. All right. So let's look at our first example. So the limit as x approaches positive 2, and there's the function. Okay. First method, always try this method first. If this method goes wrong, then change something else. First method is direct substitution. Plug it in. Plug in 2 for x. And if it gives us an answer, we're done. If it doesn't give us an answer, then we got to decide what else to do. So let's see. I'm going to plug in 2. I'm going to plug in 2 for x. So I plug in 2 up there, and I plug in 2 down here. Two squared is 4. 3 times 2 is 6, plus 4 is 10. Reduce my fraction, I get 2/5. Is 2/5 a number? Yeah, 2/5, 0.4. It is a number, so I'm done. That's the limit. That's the limit. That's when it's easy. When you plug it in and you get an answer, boom, you're done. Do it, you're done. Okay? So that's the first step, plug it in. Okay, so let's try B. So B is a piecewise function. It's got 2 pieces, right? It's got 3 minus 2x squared, and it's got 2x minus 9. It's called piecewise because it has multiple pieces to it. Right? It's like those graphs that had different parts to it. You know, it's kind of like the graphs we were looking at the other day. Like that's a piecewise graph, right? It has different pieces to it. There's 1 piece, 2 pieces, 3 pieces, stuff like that. That's what those look like when you graph them. So today, we're just looking at them this way. Okay, so still, the limit as x approaches 2. The limit as x approaches 2. So remember, for there to be a limit, I have to be approaching the same number from the right as I am the left. The right is the positive side, the greater than side. The left is the negative side, the less than side. Okay? So, first of all, the limit, so let's write this down. The limit as x approaches 2 for f of x. That's what I'm trying to figure out, right? Where am I going to plug in 2? Why 2x minus 9 and not the top one, 3 minus 2x squared? Seth, you're right. Why, though? Why did you choose the bottom one instead of the top?
Because it says when x is equal then or less than.
There you go. Equal, right? When x is equal to 2. And that's what we're looking for right now. When x is equal to 2. So we're only going to use the bottom one. I'm not going to use the top one because that's when x is greater than 2. 2 is 2. It's not greater than 2. If it was x approaching 3, then I would use the top one. If it was x approaching 4, then I would use the top one. But the bottom one is the one I want because that one has an equals. So I plug in 2 here. Let's see, 4 minus 9 is negative 5. Is negative 5 a number on the number line? It sure is. You're done. The limit is negative 5. The x value is negative 5. Okay. If you do that and you get something funky, if you get a fraction and you have something over something, like the first one I did, the one I did right before, I got a fraction, right? But that's an okay fraction. It's 2/5, right? Let's say for this answer, I got 2 over 0 when I plugged in 2. What would my answer be then? Not undefined, you're close. Does not exist, yeah.
What's the difference?
Say again?
What's the difference between undefined and does not exist?
So undefined we use when they're looking for an answer. So when we're looking for a solution at a certain number, we say undefined or no solution. But when we're looking for a limit, we're not looking at 2. We're looking for where it approaches, right? So that's why we say does not exist. Yeah. Good question. All right. Okay, so let's look at the next page, page 3. The limit as x approaches -1 for the function here. First thing, plug it in. Plug in -1 and see what happens. So 2, -1 squared minus -1 minus 3 over -1 plus 1. Okay? And then do order of operations. Exponents first. So -1 squared is +1. So you're going to get 2 times 1. I got a double negative here, so I'm going to change those to +1 minus 3. And on bottom, I get 0, right? -1 plus 1 is 0. So on top, I get 2 plus 1, which is 3, minus 3. 0 over 0. Is this does not exist? No. Why not? Exactly. The only time we get DNE is when I have something over 0. If that was 1 over 0, 2 over 0, -12 over 0, you guys would be right. It does not exist. But once you get 0 over 0, this is what I like to call you got more work to do. You got more work to do. More stuff needs to be done. There's meat still left on the bone, right? Work still left to be done. So what do we do? Well, we go to that list. We go to that list that I gave you earlier. If it's a quadratic or a cubic, or if it's a polynomial at all, factor it. Factor it. Okay, we're going to factor this one. I'll tell you this one we're going to factor. Okay, so let's go back to our problem. So this part here. I'm going to factor it. The top is a trinomial. It's got 3 parts, right? 1, 2, 3. I'm going to factor it using the trinomial parts. Now, when you factor, there's many ways to factor. I teach a certain way in Math 2 and Math 3, but your teacher might have taught you other ways, and if it works for you, do it. I'm going to teach you the way that I learned how to do. So the top is a polynomial, is a polynomial, but it's a trinomial. So when I get trinomials, first thing I look at is, does it have a GCF? Is there anything I can divide them all by? A number, a letter? Can I divide them all by 2? Can I divide them all by 3? Can I divide them all by x? Is there anything they all have in common? Just the top, just the top. Don't even worry about the bottom right now. Is there anything I can divide them all by? No. Besides 1? No. So go to the next step. The next step is, this is the way like I said, I've taught it. Since it's a trinomial, I'm going to make 1a, 1b, and 1c. A is the first term, +2. The coefficient, the first coefficient. Coefficient means the number in front of x. B is -1 because -1's in front of x, right? C is -3. Okay. So what I do is I set up a little x. The top is multiplication. The bottom is addition. Hopefully this kind of oh yeah, I think I've done that before. Good. So the top is multiplication, bottom is addition. The top, we're gonna multiply a times c. A times c. So 2 times -3 is -6. And then we're going to put b on the bottom. We're not going to do anything to B except put him on the bottom. And then we're going to play the game. What multiplies to be -3 and adds to be -1? What two numbers, when I multiply them, make the top, but when I add them, make the bottom? Right? -3 and 2. Because -3 times +2, when I multiply them, makes -6. When I add them together, makes -1. When it works for both, you got your answer. Okay? And then the next step. The next step is what I call the box. It's a 2x2 box. Kind of looks like a window pane. Looks like a window. So the window or the box, the first term, you go back to the original. The first term, the whole thing, 2x squared, goes in the first window part. The last term, -3, goes in the last window part. The two numbers that I came up with go in the two missing. So -3 and +2. So -3, +2. But they have to add together to make this -x. So what do I have to put with them so that they add together to make -x? X's, yeah. Guarantee you in Math 2 and Math 3, you did something like this. It might not have been exactly this method, but you did something like this many, many, many times, okay? Okay, so last step. Last step. We're gonna play factoring. We're actually gonna factor now, okay? So these are our answers. We have to come up with the multiplication part. So what times what made 2x squared? Well, how do you make x squared using multiplication? What times what makes x squared? X times itself. So we put an x there and an x there. One of them is going to stay, one of them needs to be a 2, right? Because 2 times 1. One of them is going to stay a 1, right? They're both 1s right now. One of them needs to be a 2 and one of them needs to be a 1. How do I decide which one? Well, you're going to look down. I'm going to put 2 up here. Because 2 times +1 will make 2x times +1 will make this guy, right? So this guy is going to be +1. 1x times what number or what thing, what term is going to be -3x squared? -3, because I already have an x, right? I already got an x there. So -3 times x makes -3x. You'll know you did it right because the last one makes sense. -3 times +1 makes -3. So I did it right. So what that leaves you with is two factored terms. Here's one of them. Here's the other one. So let's go rewrite it. So I'm going to go rewrite the problem. The limit as x approaches -1, the top is 2x minus 3. The bottom, or the top is 2x minus 3 times x plus 1. Those two are factors. 2x minus 3 and x plus 1 are factors of the green. Right? Factors means multiplication. Like if I were to give you a number like 16, factors would be all the numbers that multiply to make 16, right? 8 times 2, 4 times 4. That's what we're doing here. The only difference is these are algebraic. They got letters. 16 isn't algebraic. Okay? That's the top. Now let's do the bottom. Bottom's not as bad because it's only a binomial. So binomials, how do we factor binomials? Well, first of all, does it have a GCF? Does the yellow have a GCF? No. Is it difference of squares? There's a term there. Do you remember what difference of squares is? You have a binomial in the middle, or sorry, a subtraction in the middle. They're both binomials, and it's like x squared minus 4, x squared minus 16, 4x squared minus 100, right? The first term and the last term are all perfect squares, right? You got a squared and you got a subtraction, right? That's what difference of squares is. Okay. Is the orange guy difference of squares? No. So we leave it. I'm going to rewrite it like the way it was. X plus 1. It's a binomial, so I'm going to write it together with parentheses. So anything cancel out? Yeah. So when anything divides by itself, what does it always make? Anything divided by itself always makes a positive 1, right? So I always put a giant 1 there. So now we're left with the limit as x approaches negative 1. Now it's just 2x minus 3. That's all that's left. Because x plus 1 factored out. Canceled out, if you want to say. It's the same thing as canceling out. It's still technically there, but it's a 1 instead. That's factoring. So now what we're going to do is go back to the first step. Plug it in. Let's plug it in and see what we get. See if we get a different answer. So I'm going to plug in negative 1. So I get negative 2 minus 3, and that makes negative 5. So the limit is negative 5. Negative 5 is a number, so I'm good. Okay. Okay. That's one example of what to do when we get 0 over 0. So when we get 0 over 0, that means we have work not done. That means we're not done with the problem. When we get 0 over 0, that means we're not done. We still have meat left on the bone to chew. Okay? We still got things that we can do. What do? We go to that list. I'm going to try to give you one example from each. One example of factoring, one example of common denominators, one example of using the conjugate, things like that. And you'll know what to look for. You'll know what to look for. If it's a quadratic, like this guy, trinomial, binomial, do what you just did. But what if it doesn't have this? What if it looks like, what about this one? Let's look at this one. Let's look at D now. Okay, try this problem. Do this problem. Try step 1, plug it in. Do step 1, plug it in. Tell me what you get when you plug it in. Do we get 0 over 0? It would appear so, right? Plug in 0. 0 squared plus 4 times 0. We got a lot of zeros. 2 times 0 is 0, right? And then 0 plus 0, yep. This is not D&E. This is work left to be done. So let's take a look at this guy. Kind of looks like the last guy, except it's a little not as long, right? So we're going to do the same thing. The top is a monomial. The bottom is a binomial. Let's factor. So let me rewrite the problem. The green. How do you factor a monomial? Well, you just break it down. Can I break down 2 into anything else? It's just 2 times 1, right? So it's going to be 2 times x. If it was like 4x, I would do 2 times 2 times x. But 2 can't be broken down. It's just 2 times 1. The yellow. This one's a binomial. This one's a binomial, right? So, first step, does it have a GCF? Does the yellow? Yeah, I can divide them both by what are the two terms share in common? X, right? So I can divide them both by x. It's called a GCF. You're going to put that in front. GCFs always go in front. What does it leave after I divide them?
X plus 4.
X plus 4. So I haven't factored anything out yet. I just broke them down. Is there anything that would factor out?
X.
The x's, right? An x up here and an x down there. Can I cancel out that x? Let's say I chose another x. Let's say I chose that x. Can I cancel those two x's out? No, because the top one is a monomial. The bottom one belongs to a binomial. Monomials and binomials don't factor like that. But since this x in front is just a monomial by itself, go for it. So I get 2 over x plus 4. Yeah, so now I'm going to plug it in. Exactly. Now what I'm going to do is I'm going to do the problem like I started. Oh, simplify 2 and 4? No, for the same reason. Because 2 is a monomial and 4 is a part of this binomial. So when you're factoring, they have to be the same. Yeah. Okay. So now all that's left to do is plug in 0 like I did at the beginning. So I get 2 over 0 plus 4, which is 2/4, which is 1/2. 1/2 is okay. Okay. So that's factoring. You'll know when you can factor because there'll be a bottom, there'll be a denominator, right? These two have had denominators in yellow. You'll know when you can do that. And it's either a binomial, a trinomial, or a monomial, one of those 3. Okay. What if it doesn't look like that? Let's go to the next page. Or sorry, let's go down here. Okay. This one has a fraction, right? It has a square root, but try the first method. Try the first method, plug it in, see what you get. Because if we get something, we get a number, then we don't even have to worry about anything. But this one, so we plug in 3 for x. What do you get?
0 over 0.
We get 0 over 0, right? 1 second to pull up my notes. Okay. Yeah, so if we plug in 3, right, I get square root of 3 plus 1 minus 2, and then 3 minus 3, right? So 3 plus 1 is 4. Square root of 4, 2. And then minus 2 on top, 0. And then 3 minus 3 is 0. Get 0 over 0 again. So that means there's work left to be done. That means you're not done yet. So anytime it looks like this guy, we can't use the factoring steps. Why not? Because it's got a square root. If it didn't have a square root, we could do exactly what we just did earlier, what we just did on the last. So what do? This is where we're going to use something called conjugates. So conjugates are the same thing, just reverse different signs. So let me show you what I mean. Let's see. Let me close this. So we're going to do something called multiply by the conjugate. Okay. All right. So let me give you an example of that. So which one do you start with? Well, you start, which one is causing the issue? Which one is causing the issue for me not to do what I did the last two times? The bottom or the top?
The top.
Bottom kind of looks like the same like we were working with, right? X minus 2, X, it looks similar to what the bottom does, what we've been doing. The top is the one that's causing the issue. So what we're going to do is we're going to multiply by the conjugate of the top because that's the one creating the issue. Okay, so what does that mean? Well, first thing we're going to do is rewrite the problem. The limit as x approaches 3, square root x plus 1 minus 2, and then x minus 3. So we're going to multiply now. We're going to multiply by the conjugate of the top. The top is actually a binomial. It's actually a binomial. This is one term, and this is another term. What do they have in between them? They have a subtraction, right? That's how you can tell the terms, right? Because of plus, like this last example that we did. How did you know that the bottom was a binomial? Because there was a plus in the middle, right? Same thing here. So this guy is actually a binomial. So what we're going to do is we're going to rewrite that binomial. Square root of x plus 1 and then 2 on top and on bottom. But instead of minus, we're going to use its conjugate. Its conjugate means the opposite binomial. So instead of minus, I'm going to put a plus. Plus. That's what a conjugate means. So like the conjugate for x squared minus 4 is x squared plus 4. The conjugate for x squared minus 16 is x squared plus 16. 4x squared plus 100. That's what the conjugate is, okay? Okay. So when we multiply straight across. I'm not going to multiply yet. I'm just going to take inventory of what I have. So I have this binomial times this binomial. And then on the bottom, I have this binomial times this binomial. Oops. Okay. Okay. So I'm going to multiply the top. So I'm going to multiply the top binomial versus the other binomial. The only difference between the binomials on top is one has a minus 2 and one has a positive 2. So when something is, the only difference is the sign in the middle, right? Kind of like these, right? There's an easy way to do it and not a hard way, but a little more complicated way. Okay, so I'll show you both. X squared minus 4, that's difference of squares, right? What would that break down to? Does anyone remember from last year or the year before?
X minus 4, x plus 4.
Close, 2, x plus 2, x minus 2. And then 16,
X plus 4.
There you go, x plus 4, x minus 4. And then this last one here, since it has a 4, right, it's going to be 2x plus 10 and 2x minus 10, right? The reason we can do that is because it's difference of squares. So x plus 2, x minus 2, conjugates. X plus 4, x minus 4, conjugates. 2x plus 10, 2x minus 10, conjugates, right? Aren't these guys conjugates too? Because they have, the only difference is they have a plus and a minus, right? They're conjugates of each other. So we're going to go the opposite way of what we just did. We're going to go this way. All right. So right now I have x square root of x plus 1, square root of x plus 1. To get back from over here to this side, what do I do with the first guy? To get back to here, here, and here. By itself, right? Square it. Square it. That's what I'm going to do over here. I'm going to square it. I'm going to square the first guy. Square the first guy. And then how do I get 4? How do I get 16? How do I get 100? What did I do there? Square them again, right? Square these guys again, and that's how you get 4, 16, and 100. So I'm going to square 2 because that's what was there. What sign always goes in the middle? Minus. The bottom, are the bottom difference of squares? No. So I can't do that. I'm going to leave them alone. I'm going to leave these guys alone for right now. So x minus 3 square root x plus 1 plus 2. How do you square a square root? What happens? In other words, what happens when you square a square root? Yeah, you just it's kind of like taking 2 steps forward and then taking 2 steps back. You just get rid of what was there. So the square root of x plus 1 squared is just x plus 1. Minus 2 squared, 4. The bottom, like I said, leave the way it is for right now. We'll come back to it in a second. I can simplify the top. What is the top going to become? X minus 3, right? Because positive 1 minus 4 is minus 3. Rewrite the bottom. Is there anything I can factor out? X minus 3. Because the binomials are exactly the same. So that leaves me a 1 on top, and then an x plus 1 square root plus 2. Now plug in. So we had the limit as x approaches, what was it, 3? 3. Now let's plug it into the new, or to the simplified version of the original. It's the same one as the original, it's just simplified. I factored it out. So now when you plug in 3, do we get an answer? We're going to get an answer. Let's see, what answer do we get? Yep, square root. So we get 3 plus 1 is 4. Square root of 4 is 2. Plus 2 is 1/4. All right. I'm going to give you, last thing we're going to do. Last thing we're going to do, I'm going to give you one problem like that. So find in the back, I left a whole bunch of blank spaces. Use the bottom half of the last page as extra examples. So we'll call this example 2E or E2. E part 2, whatever you want to call it. Okay, I'm going to give you another one just like that so you can try it. And then we'll be done for today. Here we go. Okay. So the limit as x approaches 4, x plus 5 square root minus 3, and then x minus 4. That's the question. I'm going to give you the answer so you can check to see if you get the right answer. So the correct answer is going to be 1/6. That's going to be the correct answer. Most of the time, these questions here, you're going to get a fraction for it. Okay.